So thanks for staying up all the way. I think probably most of you are waiting for drinks, so that's good. I promise I won't keep you from that. So yeah, so I wanted to talk about augmented reality in the context of the next, as the next computing revolution, and for us, we look at it from the context of the mobile revolution that started 20 or so years ago and still with us today. In ARM, we learned a few things along the way, and we want to share some of that insight with you, and also find out or discuss how this time around is very, very different in a few fundamental ways. We're going to be talking about ever more, increasingly more powerful hardware. We're going to be talking about APIs that connect all these different pieces of hugely complex software together, and we're going to be talking about how software optimization delivers, all those incredible performance experiences. So I've already been introduced, but I'm Pablo. I work in ARM. I head the developer ecosystems team, and I work with developers, with content creators to deliver, experiences on ARM-powered devices. And just a very quick introduction about who ARM is, because I'm sure there's a few people here who may not know who ARM actually, what do we do. So we powered a lot of those a lot of devices. By our estimates, about 125 billion devices over the last 25 years or so, since ARM was created. 20 billion devices with ARM-based architecture or technology will be shipped by our partners this year alone. About over 95% of all mobile devices. And one thing that not very many people know, 1.2 billion Mali GPUs will be shipped this year from our mobile GPUs from our Mali family. So our origins are back in around in the 90s. We started with the one thing on the left. Does people know what that is? It's a BBC Micro. People in the UK know. It's something called BBC Micro, which was developed actually by Icon Computers, and it featured the technology that would become eventually what our ARM architecture is today. And the one on the right is the Icon. The BBC Micro sold about 1.5 million devices, which was huge at the time. And the one on the right is the the Apple Newton, and that is the first processor, the first device with an ARM architecture inside its SoC. So our origins already back in those days were very portable communications, although mobile started a few years earlier. Mobile started in the 80s, and those days you could buy a Motorola DynaTAC, I think it was called, about $3,000 would set you back. So how did something that that break $3,000 became this massively the most ubiquitous computing device in history? So a few things needed to happen. We needed the right infrastructure in place. We needed base stations to give coverage, and we needed all the backend services and infrastructure to move all the data. And obviously, all of those devices needed to talk together, to talk to each other. So we had to create, or people had to create standards like GSM, and those standards enable all these devices to interoperate together. And right at the beginning, all those new things were fairly cool and niche, and that's how things have normally been in tech. Things start very cool and niche and fairly expensive, and then they start to become more ubiquitous. And but even as they were still fairly niche, those devices did appeal to basic human needs. For example, they need to be able, to be contactable and to be able to communicate with other people regardless of where you are, whether you are home or at work or elsewhere. And those needs would be those devices would transform our lives, over the next 20 years or so. And then we had we had iterations of technology that drove down the cost, power consumption, and size, thanks to the power of Moore's law, and that at the same time they will drive the power, the capabilities of the devices grew exponentially at the same time. So that's all sort of what happened, and what did we learn from all of that, and how does that apply to AR? So the first thing we learned is that we actually, a company like ARM, needed to provide some building blocks, some flexible technology for people to innovate. We never set out to dictate how the market works. We just build products and services and tools that allowed other people to experiment and to create products with a few missteps along the way, like everyone does. But those products would eventually evolve into the products that became solutions that became really successful. So we never dictated the right approach, but allowed other people to decide what works for them. The other learning is market dynamics. In a massively complex industry like mobile, with operators and devices and all these other sort of elements, market dynamics and consumer needs and all these forces would dictate who wins and who loses. And it's not for us or anyone else to decide how that's going to happen. So what was really important for us is to, as you say, provide that technology, perhaps seed it into the market and decide and let the market decide who wins and who loses. And all of that brings us to AR and VR. And I'm not, dogmatic about what constitutes AR and VR and MR and XR, but all of those technologies have a combination of vision and cognition and augmentation and user interface or HMI. And vision, is all these devices look out to see the world around us. In some cases, also look inside. Things like eye tracking, eye movement are becoming very important as well. And obviously, vision is not used if you don't make a sense of it. So the augmentation part of it is transforming that scene that you are seeing into the objects, and also, very importantly, into the context that it represents. And once you have the vision and the context, or the elements and the context, you can start creating immersive media around it. And that's what actually makes this technology so exciting. I think the other important aspect is all the security, privacy, and even identity implications that all this generates. But I'm not really going to touch much on that. And those technologies are going to transform. I mean, this is pretty obvious, right? We all know that this is going to happen. It's going to transform a lot of industries. It's going to transform the way we live our lives in the next few years. Some of them in pretty obvious ways, like cinema or gaming or entertainment, and some others in ways that we can't really anticipate today. But I think it's going to be very, very exciting. So I think this is one of the key differences between mobile and AR or VR. I think the form factor decisions we're making are going to be pretty fundamental, and that is because these devices are going to be wearable, are going to be next to our body. Back in the mobile days, key really important decisions were, or challenges in design were how to remove the antenna from my device, or whether you wanted a physical keyboard or not. Or even if you really need a headphone antenna or headphone jack or not, this is sort of the big debate. Now whether it's all-in-one VR or devices with companions or all-in-one AR, the wearable nature of those devices is going to actually have huge implications in the way those devices are designed and the way they are used and the constraints around them. For example, here on the right, you have all-in-one AR. Some of those devices are going to be possible in certain timescales, depending on what technology is available when. If you think of all-in-one AR, Google Glass or Snap spectacles, you could put in that category, but we all agree that that's not what we believe AR is going to be able to deliver. So going on with the challenges, the form factor challenges, I think there's going to be a huge amount of emphasis put on things like weight and thermals. Weight, when you think about the battery constraints, batteries these days give you about 10 to 25 watt hour per 100 grams, and a typical pair of glasses weighs about 25 grams. So there's a huge disparity there, and something's going to be give at least in the foreseeable future. And thermals, again, is the same thing. The thermal budget of something that's is around your face is going to be very, very limited. So that's going to require a lot of compromises initially. And then solutions are going to have to be system-wide. I think these workloads we are looking at, this kind of really complex use cases with lots of different computation, vision, and graphics, and so on, require system-wide designs. So all of that means that the implications for all of those design choices are going to be suffered or felt across the stack. We normally in ARM we look after the left-hand side of this value chain, but as you start looking at those implications, it's very, very clear that everyone from the hardware vendors all the way to the software developers, content creators, tool vendors have to think about how these devices are going to be designed and used. And as part of my team, we look after developer tools, developer ecosystems, and how this content is being deployed. So I think that right-hand side of that value chain, the software platforms are going to become, and this is probably one of those key differences as well compared to the mobile world. They are going to become one of the essential parts of this new revolution. I think when you look at back the mobile days, mobile was all about hardware and embedded firmware. These days, software. Then you started to have rich operating systems with smartphones, and there was a few to's and fro's, and in the end, iOS and Android won that battle, if you want. Those platforms are based on an operating system with apps and services on top, and you can't guarantee that model is going to translate very well into an augmented reality world. I think if you think about the comparison, the value in traditional or feature phone or traditional mobile was in voice and messaging, and that value translated in the smartphone world into internet services, and then so that was a big fracture there. And I think we can see now the value is going to be in AR. The value is going to be delivered in the world around us. So it's not going to be in a flat screen with an array of icons. It's going to be the whole world around us. That's another fracture that will enable innovation. It will enable disruption. So some people call that the post-operating system world. Of course, operating system is still going to be there, but it's going to be completely transparent. It's going to be hidden from the user. It's not going to be obvious. And again, those developers are going to be absolute key to the success of these new devices. I think whichever platform provides a richer world, a more augmented world, a more interactive, a more exciting world, that's the device or the platform that's going to succeed, and that is going to be enabled by developers. So where are we in that transition, in that revolution? I think this is kind of interesting. I was listening to Charles Fink earlier, and he was, a lot more. He's much better storyteller than I am. I like graphs and plots. So I look at it from this analytical point of view, and I take the adoption curve of three technologies: smartphones, TVs, and PCs. And they are kind of representative of AR because they are all consumer technologies. They all are roughly similar price points, and they have all been evolving very rapidly over years. Obviously, what we would like to know is where are we and what AR is going to look like. Is it going to look like more like a smartphone, really rapid adoption, or is it going to be very slow, steady, more like a PC? So, so if you look at the first sort of commercial viable VR devices, the Rift in 2013. Then we had the first mobile VR-based devices a couple of years later. Then we had a HoloLens, and then the first AR SDKs, ARKit. Apologies, Vuforia is not there. It should be. So it's all happened very rapidly, but in the context of these timescales that we're looking at, is still relatively new, right? And what we really want to know is AR, VR going to be one of those curves, or is it going to be perhaps a bit more like a video consoles, which never really actually took off 100% of adoption, and that, by the way, that's absolutely fine. I don't think anyone in the console market will complain about that kind of success they've had. So is AR going to be a bit more like smartphones? VR going to be a bit more like consoles? We don't know really, obviously, but I think what's really important is what's going to enable that hockey stick. What's the inflection point? When does that happen? One of the things that will be required is a lot of computing processing power. That's kind of where we are now. There's a big inflection point as well in computing power in mobile devices. This comes from an announcement we made a couple of weeks ago when we published our roadmap for the first time. And we see from, in the next 5 years or so, the compute power on mobile devices is going to grow by about 250%, give or take, 2.5x. And that's a trajectory that actually goes over what the Moore's law traditionally predicts. If you believe in the Moore's law, and of course there's a lot of people who don't really believe in the Moore's law anymore and think, well, the Moore's law is dead. And I like to quote one of my colleagues, a guy called Sean Ellis, who coined what I call now the Ellis law, which says the number of people announcing the death of Moore's law doubles every 18 months. So that's, of course, very tongue-in-cheek. But I think the point I'd like to make is that the computing power is growing still. It's just not only growing from the traditional places, smaller geometry, better process, more transistors, and so on. There are a number of new workloads, ML, vision, imaging, and so on, that are starting to require new processing capabilities, and those are very highly optimized in hardware as well. For example, the device on the left is a new processor, general purpose processor, which delivers 30% performance increase, but 4x machine learning improvement. And a lot of the machine learning that's being enabled these days on mobile devices actually runs on the CPU. So this is very, very important. On the other side, you have a GPU, which again produces the usual step on performance, and again 2.7x on machine learning, which was already much accelerated. And then you have dedicated NPUs and imaging processors, and lots of different processors dedicated to different workloads. And of course, on top of that, you have a huge, vast collection of software to deliver those experiences, delivered by multiple vendors on multiple platforms, and those pieces of software need to interoperate using APIs. I think APIs, we kind of look at them in the same way as people looked at GSM standards back in the 80s. Is the glue that makes everything work together. And they are key to experimentation. And we particularly in ARM look at specifically at APIs that manage hardware interactions, like Vulkan for graphics or OpenXR for VR, AR. And one particularly interesting use case is machine learning. There's a lot of frameworks, commercial frameworks already out there. Those frameworks, when translated into mobile, really need to work in the most efficient way. And use the resources in the hardware. So there's something we've created called ARMNN, which is open source. We open sourced it, and it's available on GitHub, that optimizes those frameworks for the particular hardware you have on your mobile device. It's already available in a couple of Linux and Android devices. So that optimization that I was talking about is actually going to be critical as well to deliver that extra level of performance. This is just an example of a piece of, one of the software elements in our stack. Without changing the the hardware or changing the workload. Since launch and over the next sort of 12 to 18 months, 12 to 14 months, we cut the execution time in half. Obviously, cutting also the power consumption in half at the same time. So the message here, this is one of the key messages here, is software optimization. When you think about the amount of software running on those devices, you think about machine learning and imaging and all these contextual sensors and so on, the amount of inefficiencies that you could potentially have in your software stack are absolutely staggering. So this is going to become very, very important to deliver that performance that we're looking for. In terms of performance, modern compilers are really good, very efficient, and they do very well things like vectorization and loop management, loop unrolling, and so on. But sometimes you actually need to dig into that application you have and understand what's going on at that system level. So at that point, profilers, debuggers, analyzers are becoming really useful. In ARM, we have a couple of profilers, a system level one called Streamline, and then a graphics profiler. Doesn't matter, really. The point is vendor tools are important. If you are working on a platform, use the vendor tools to understand what's going on, because you probably can squeeze a lot more performance that you have today in your device. So that's it. Summary. I think in the hardware technologies are becoming more powerful. There's more of them available. They are more flexible than they've ever been before. The workloads, again, they are becoming ever more complex and more interesting in a way. Heterogeneous compute is not going to go away. Those APIs that I was talking about are going to enable experimentation and rapid prototyping, and are essential part of software development. And again, optimization of the software can be a key differentiator, because it's going to drive cost and performance for your device, so use it. And that's all I have. If you want to know more about what we have in ARM, there are a few resources for developers. All of that is available for free. Graphics, ARMNN, and lots more in arm.com, developer.arm.com. Thank you very much.
Thank you so much, Pablo. That was an excellent presentation, even with the Vuforia oversight. We do have time for some questions from anyone in the audience. Actually, I have a question.
Yep.
So you mentioned a bunch of use cases, one of which being social media. In your opinion, when we have this AR, XR revolution, what area do you think it's going to affect most?
You know what, we were talking about that earlier. I think for VR, it's everyone sort of tends to agree that VR is either a professional thing for training, and I mean, there's a huge number of use cases for VR, and then there's the big one, which is entertainment, whether at home or on these big spaces. I think that's where it's going to stay for the time being. I think VR in location-based VR, particularly, I think is quite particularly interesting. Things like the Void. I think that's probably going to deliver the best experiences, and the benefit those places have is that they can invest in the hardware that you probably can't afford at home, and they can sort of invest in the environment as well. AR, I think it's still very much up there. I think hardware, consumer hardware is, as in dedicated consumer hardware, for the reasons I've just explained, is still quite a long way out. But all the use cases you could enable with things like ARKit, ARCore on your mobile device, and then perhaps intermediary devices along the way, are going to start enabling really interesting use cases. And I think developers will find some really creative ways of using that.
Yeah, I agree. Thank you.
Yep.
Are there any other questions from the audience? All right. Thank you so much.